In our last episodes, we have already talked about the humanoid brain, but we didn't discuss what it is and what it does. So we want to deep dive into software that is controlling it in today's episode. So stay with us and enjoy.
Automation Awakenings, your weekly dose of best practices for logistics automation.
Welcome to another episode of the Automation Awakenings podcast. And I hope you had relaxed and nice Christmas holidays. And now welcome back to some tech talk. After finishing our last episode with the brain of a humanoid, today we're gonna dive deeply into this brain. And we will do this together with my favorite brain next to me. Welcome, Matthias Koblitz.
Thank you so much, Olli. Yeah, it's good to be here, and it's good to sit here as two brains, at least hopefully, and to finish this year with another really interesting episode on software. And in the preparation for the episode, we decided to actually go from basic to advanced, so that we do not lose you guys on the way. So let's start and let's talk about the most basic software that the humanoid needs to, be a humanoid.
Yeah, well, Matthias, when I think about a personal computer, the absolute basic software is the BIOS.
Right.
Do we have something similar in the humanoid brain?
Yeah, actually, yes. You can even take over two letters from BIOS and just add another one. And you're going to end up with ROS, and that's a robot operating system, which is basically a framework for software development in the robotics sphere or scene. And it's, by the way, also used in mobile robots a lot because it is managing or bringing together algorithms and actuators or motors, and is really, making a robot move, so to say.
That means I need the ROS, that I know what type of actuators I have, how to control them, to move a leg, a limb, a hand, without any interaction and so on, just the basic functions that I can move the robot.
Yeah, so you can basically say that ROS is there to manage the interaction between hardware and algorithms.
Okay, that's
nice
clear.
And easy. So it could be all kind of hardware components that need to do something. If you talk about the skeleton, for sure, Ross wouldn't tell the carbon fiber to bend or something. But as long as we talk about actuators, sensors, other devices like motors, gearboxes that are driven by electrical signals that are steered by algorithms, ROS is the place to be, or the foundation of everything to be, so to say.
Okay, understood. So I can start moving already.
Yeah, if you lie on the floor like a beetle and you just move your limbs, then yes, because there is still something very important that is missing here. And it's basically the control system software. So there's all kind of softwares that are steering on how the robot, how the humanoid is moving in terms of locomotion, in terms of balance, in terms of dexterity.
Yeah, and speaking about locomotion, as soon as I start moving, there are three things I need to know. Where I am, where I want to go, and what's the route.
Exactly. And this is basically then the next batch of softwares that are very important to the humanoid brains. So basically leaving those basic softwares, those basic applications that are really like the foundation, and we are moving into a new section here. And I would like to open it up with computer vision software. So the software that is basically there to interpret and to and to deduct decisions or signals from things that the humanoid detects in terms of vision, in terms of objects that are around him.
Yes, and the software stack is in general pretty similar to what we already know from classical mobile robots. Yeah, they're using SLAM technology, localization and mapping, laser, and so on. And this input is then processed in a typical SLAM processor, which we already well know from our mobile robots colleagues.
That's right. So for sure, we are reusing stuff. We are reusing software that is already out there, and we adapt it a little bit to make it fit the humanoid use cases a bit better. Right. So now I can detect objects. I can judge them. What else? Have to help me out here, Ollie. I lost my red thread, to be honest.
Well, you can hear things.
Oh yeah, right.
And you need to process what you've heard, right?
Exactly. And this is where speech recognition is kicking in. So software that is helping the robot to interpret language, to interpret sounds, and use that for his job, for his interaction with the environment.
The buzzword here is natural language processing.
Oh yeah, very nice.
NLP, what we know from the Alexas and Siris out there, which is also used for the humanoid. And speaking about interaction, there could be also another form of interaction by interpreting gestures,
right?
Human gestures. Yeah. So let's say as a fun thing, you can wave your hand, and the robot will also wave its hand. But could be also used to stop the robot or to call the robot with your hands. And for that, we need software to interpret this information we get from our video system.
Yeah, so we can call it behavior planning software, and it's there to react to stimuli in real time and to determine what the humanoid should do when someone is waving, for example. Just ignore it, stop, jump, wave back. There could be 1,000 options here. And this is exactly where we need this category of behavior planning software to take over.
Yeah, I think now we are ready for the next step.
Yep.
And this is the huge category of artificial intelligence and learning.
Correct. It's the crown of the software that is used in a humanoid. Of course, not surprisingly, but it's definitely making the big distinction between, for example, mobile robots to a big extent, because they are really awarding human-like abilities and human-like behavior to a humanoid. So maybe let's start with AI.
Sure, AI is making many things possible, and to avoid using it only as a buzzword, I found a very interesting example what makes AI possible with the humanoid. Imagine you would like to pick a carton box with this robot. Mm-hmm. In the past, you need to do your simulations on your own, try and error, and so on. Now with AI, the humanoid can perform the simulation alone. Yeah, try different type of hand movements, pressure, angles, and you can let him try and error for some time until he finds himself what's the best option to grab a carton. he might destroy some of them during this test, but he can even grab another one and work for some hours or days until he performs this task in the best way. And it's a great example of learning.
Yeah, totally. So in general, I think AI is just really boosting the topic of decision making, of adapting to a changing environment, and also to planning tasks. So that's something that we expect from the humanoid to do in a similar way as we would do it as a human. Nice example with the box. When you're a kid, you would also do it 20,000 times before you are able to do it in the right way. So the robot needs to learn quicker, for sure. And this is where AI is really helping him to skip a lot of this try and error loops.
Yes, and secondly, of course, it's helping a lot to recognize what is in front of the robot. Like, is it the carton box where I need this and that pressure, or is it another type of box? And in the beginning, you need to train him, to explain to the robot, okay, this blue box is a different type, and so on. But later on, the robot can decide himself based on the picture he got, even if maybe the light is not perfect, which type of object he's actually trying to grab right now.
But that's more towards machine learning already, right?
Yeah.
Okay, so we are leaving AI a little bit here, and we're going into classic machine learning, where you train a robot or a kind of software with thousands of pictures of a certain box that you need to grab, and this is where the humanoid is basically sourcing his decision making from.
I think the whole category of AI and learning in general is also what makes a big difference in comparison with the classic mobile robots. For the classic ones, this type of software is not as interesting because they're usually performing repetitive tasks and they don't need to decide so many times.
Yeah,
maybe on
right.
the routes, yes, fully agree which route is the best to take, share information among a swarm.
Like autonomous navigation, basically, right?
Exactly. Yeah. There, of course, AI is beneficial. But that's it. For a humanoid, there are so many new options to take and to decide. And there we need AI. And only thanks to AI, we are now talking about grabbing carton boxes.
Yeah, totally agree. The big question, and that's maybe also a good one for closing, is where you want the humanoid to source the data from. Does it have all of these information sitting inside its own CPU, GPU, whatever? Or do you want the mobile robot, the humanoid, to source it from a cloud? And of course, there's pros and cons for each of these aspects. We can quickly discuss it. Olli, what do you think? What's best?
Yeah, well, first of all, there are parts of the software which must run on the robot, like the operating system.
Yeah, of course.
This cannot be in the cloud.
Yeah.
Because in general, everything what is required for safety, for basic movements must be, let's say, on the robot, on premise.
Yeah.
Yeah. Everything else, especially what requires a lot of data, AI, deep learning, and so on, it can only be outside in some type of cloud, wherever it is. And as soon as we have data used, which is outside of the robot, we have the latency topic.
Yeah, exactly.
Imagine your robot is standing in front of this carton box and then it's like loading and loading to get the data, how to grab it and which pressure it needs. Yeah, would be very weird and we will lose a lot of productivity just because of a bad internet connection.
Yeah, right. And I mean, that's one of the risks of running humanoids that source data from clouds. I think that's a very interesting topic that we could rediscuss in a later episode as well. But I think you need to like really carefully decide what to use, like what type of computing to use for which function, to provide the best mix, the best coverage, and the best resilience also towards unexpected situations like Wi-Fi crash or whatever disturbances that you can have as a robot.
Yeah, and with this interesting question, we can come to an end of this episode and also of the year 2024.
Yeah, that's right. Started very basic with the question on why you need to automate, and now we are talking about cloud computing in a humanoid. I think it's been a hell of a journey, also for the two of us. We enjoyed it a lot, and we hope you also enjoyed it. And we would, of course, like to thank you a lot for joining this journey, for leaving your comments, for writing your questions to us. And we hope you're going to stay with us also next year, because there is so many important and interesting topics that we need to discuss to make sure that you guys can awake the future of logistics in your facility.
The whole team of Automation Awakenings wishes you a wonderful and awesome Happy New Year.
Happy New Year. See you in 2025.
This was another episode of the Automation Awakenings podcast. Visit us at automation-awakenings.com.